Okay, let's just jump right in. Have you ever wondered how the pros actually take massive, heavy AI models out of the lab and put them into the real world? It's a huge bottleneck for so many developers right now. Today, in this explainer, we are breaking down a really fantastic open source blueprint created by Kiran Ramayanam. It's his LLM Inference API GitHub repository. If you want to know how to wrap resource-hungry language models into clean, super efficient web services, you are in exactly the right place. We're going to tear this architecture down piece by piece.
So here is the million-dollar question we have to answer today. How do you turn a massive large language model into a fast, scalable API? Because look, it's one thing to run a script on your laptop while your cooling fans sound like a jet engine taking off, right? But it is an entirely different beast to build a server that can handle multiple users at the exact same time without crashing or completely freezing up. These pre-trained Hugging Face models are incredibly powerful, but man, they are computationally greedy. If we aren't careful with our design, literally a single text prompt could bottleneck your entire application. So we're going to see exactly how to prevent that.
To get there, here's our roadmap for this explainer. We'll start with the core concepts of production deployment, peek under the hood at the technology stack, walk through the actual architecture, look at how testing and Docker keep things stable, and finally, we'll talk about scaling up for enterprise-level performance.
All right, let's dive right into our first section, bridging that massive gap between training a model and actually running it out in the real world. And to do that, we first need to talk about the foundation, the technology stack. So what are we actually building with here? The developer chose FastAPI for the backend, paired up with Uvicorn for the server and Pydantic for validation. And honestly, FastAPI is an absolute game changer here because it's built from day one for asynchronous operations, which, trust me, is a total lifesaver for AI. For the ML side, we're relying on Hugging Face transformers and PyTorch, which is pretty much the industry standard right now. Then, to make sure it all actually works before shipping, we've got PyTest and HTTPX. And finally, Docker and Docker Compose handle the containerization, meaning we can package this whole shebang up and run it anywhere with just a couple of commands.
Okay, moving on to the architecture, I want to show you the actual journey of a single request.
Let's trace the exact path the data takes. Step 1. A user sends a request over the web, say asking the AI to write a quick poem. Step 2. FastAPI intercepts that request and immediately hands it off to Pydantic to make sure the data is actually valid. If it's messed up, it gets rejected right on the spot. No wasted time. Now, step 3 is where the real magic happens. Instead of forcing the web server to do the heavy lifting of running the AI model, FastAPI passes that task over to a thread pool executor. Finally, in step 4, that background thread talks to the Hugging Face model, cranks through the heavy CPU math to generate the text, and fires the response right back down the chain to the user. Now, what's really interesting about this slide is how strictly we guard the gates back in step 2. Just look at these Pydantic validation constraints. The prompt is required, but it's hard cap between 10 and 500 characters. And max_new tokens, which is how long the AI's answer is allowed to be, maxes out at 256. Why are we so strict? Well, without these rules, a user could accidentally, or maliciously, send a 10,000-word prompt that would force the server to allocate a massive amount of memory and could literally take the whole system down. So Pydantic is basically acting as our bouncer here.
Let's talk about a huge efficiency win, singleton model loading. This repo explicitly sets things up so the massive Hugging Face model is loaded into memory exactly once, right when the app starts. Think of the AI like a brilliant but, very grumpy professor who takes forever to wake up. If you have to wake the professor up, explain their entire life's work to them, and then ask a question every single time a student walks in, well, your line is going to be out the door, right? Singleton loading means we wake the professor up once in the morning, give them their coffee, sit them at their desk, and just hand them questions all day long. It completely wipes out the massive delay of reloading gigabytes of weights for every single API call. In building on that, let's compare 2 ways to handle the actual text generation. On the left, we've got synchronous blocking. Without async, your server gets a prompt, the CPU starts chugging, and the whole server basically freezes. If a second user shows up, they're completely ignored until the first one finishes. Not great. But on the right, we have what this blueprint actually uses, asynchronous inference, using that thread pool executor. It's like a restaurant. FastAPI is the waiter. They take your order, walk to the kitchen, and hand the ticket to the chef, our executor. The waiter doesn't just stand there staring at the oven, right? They immediately go back out to help other customers. This keeps the API incredibly fast and responsive, even while the model is sweating it out in the kitchen. And this brilliantly illustrates why we need to make sure everything is rock solid. Let's look at testing and Docker deployment. the developer didn't just write this code and cross their fingers. We've got a really smart dual testing strategy. First, unit tests specifically check that our Pydantic bouncer rejects bad data and that the singleton loader actually only loads once. Then integration tests act like real users, hitting the endpoints to ensure the whole pipeline flows perfectly. And to make it portable, the whole thing is wrapped in Docker. With Docker Compose, you can spin up this exact environment, same Python dependencies, same system config, with literally one command. It completely kills that classic, "well, it worked on my machine" excuse.
Finally, let's talk about the future, scaling this up for the enterprise. So we have a really solid foundation, but doing heavy AI math on a CPU is always going to have latency limits. To push past that, the repo lays out a roadmap. The obvious next step is GPU acceleration for a massive speed boost. But we can also use model quantization, basically shrinking the model down to 8-bit or 4-bit precision so it uses way less memory without losing much quality. Converting it to the Onyx runtime is another great trick to optimize the math. If you're dealing with huge traffic, you'd want request batching, grouping multiple prompts together to run them simultaneously, and response caching. So if 10 people ask the same question, you only compute the answer once. Add Kubernetes into the mix to horizontally scale our Docker containers automatically, and you've got a true enterprise powerhouse. And that is the whole shebang. We've seen how combining the raw power of Hugging Face with the async capabilities of FastAPI, locking it down with Pydantic, and wrapping it all up neatly in Docker creates an incredibly robust blueprint. Sai Kiran Ramayana laid the foundations perfectly here. So what does this all mean for you? Are you going to keep relying on slow, blocking scripts, or are you ready to adapt this blueprint and deploy your very own enterprise-grade AI solutions? Grab the code, spin up the container, and see what you can build. Thanks for hanging out with me for this explainer, and keep exploring.